Welcome back. This is an Aleks training video on using the general properties of equilibrium constants. An equilibrium constant, we call it K, is just a way for you to instantly tell are you making more products or more reactants. Remember, both of the reactions are going on at the same time. Anytime you have a reaction, you're going to have its opposite reaction. But you do not know exactly which rate is going faster. If the forward rate is going faster than the backwards rate, then you're going to make more products. If the backwards rate is going faster than your forward rate, you're going to make more reactants. And so it's like a tug of war. So in the case of a K, the K is based on a reaction. I've got it at the top here. It's concentrations. So in the case of this chemical equation, the chemical reaction, you're making hydrochloric acid and you're making carbon tetrachloride. That is up here. These are concentrations. So you conduct an experiment, you measure the concentrations at different times, and as you look, you say, okay, I've got this much of stuff here, I've got this much stuff here, divided by the amount of stuff that you have that are your reactants, the stuff on the left. So what's the concentration of the chlorine? What's the concentration of the methyl chloride? So you're looking at the concentrations throughout the different stages of the reaction. And if you have tons and tons of the top, imagine that you had 1,000,000 of these and 1,000,000,000 of these and 6 of these and 9 of these. You have a huge number on top and a little tiny number on the bottom. Well, that's showing you that you have lots and lots of product. Let's say you have 9 on the top and 6 on the top and 15 million on the bottom and 20 million on the bottom. You can see that you have lots and lots of reactant and very little product. That's showing you that you have that it's more to the left, that you're going more towards reactants than products. So the number, if it's huge, if K is very, very big, then it's suggesting to you that you have products, lots of products. If the number is very, very small, okay, less than 1, very, very small, not negative, but very small, less than 1, it's showing that you have lots and lots of reactants. So the K is an instantly easy way to see where is this reaction going. Is it going to the right? Is it going to the left? Okay. So in the case of this K, I've got 7.32 times 10 to the 4th. Okay. So that is 4 zeros. That's 70,000. So it's a big number. So if this is a big number, it tells me that the top must be big and the bottom must be little. Otherwise, you couldn't get a big number. That means you have very little stuff on the left and lots of stuff on the right. Well, that's showing you towards the products. That's meaning, I've got an arrow. You've got a reaction that the reaction rate is going fast to the right and slow towards the left. And so as these guys are making more than these guys can make, which means that anytime you stop, you would look and you would have more product than you have reactant. Okay, so the first thing that I want you to remember is that the size of your constant, your size of your K, tells you whether reactants or products dominate at equilibrium. When these two stop moving, then you look, and whatever your K is, you're going to have more products. If this K is going fast, if this rate's going faster than this, you'll end up with more products. Okay. The second thing is that the K for the reverse reaction equals the inverse of K for the forward reaction. So inverse just simply means flip this upside down. Flip this upside down. So let's say I have a big K. I have 1,000,000 and 1,000,000 and 7 and 7. Okay? So 1,000,000 times 1,000,000 times 49, or divided by 49. So I'm going to have a big, big number. If I inverse that, if I flip this upside down, flip it upside down, then you're going to have a very tiny number divided by a huge number. And that means you're going to have a very, very little K. So what you're going to do is, if you see it backwards, see I've got HCl here, HCl here, CCl here, CCl. basically it's exactly this reaction backwards. All you're going to do is take your K and invert it. You're going to have a 1 over X button on your calculator. 1 over X is an inversion button. Okay, so you simply just flip it upside down, and that's your K for the backwards. The next thing you have to realize is that in order to make this, we've made these Ks before. In the case of this guy, I've got Cl2, CHCl3, all of these are ones. I've got 1 to 1 to 1 to 1. And these are all ones. The concentrations are to the first power. So if I have Cl2, okay, Cl2, then that's going to be Cl2 concentration to the first power. If I have CH3, that's a concentration of CH3 to the first power. But if I had a different number here, if I had a 2 or a 3 or a 1 or a 4, then whatever the coefficient is becomes the power of your concentration. So look what's happened in the third question. They've taken the original equation, Cl2, CH3Cl, okay, it's all here, but they doubled everything. They made a 2, they made a 2, they made a 2, they made a 2. Well, suddenly now I've got to square all of these guys. So I have it written here, K for the reaction multiplied by N, so if I'm multiplying everything by 2 here, is the K raised to the power of N. Okay, so if I double it, I take the K, whatever my K is, 7.3 times 10 to the 4, and I square it. If everything is tripled, okay, if every single thing is tripled, now not just one, but if every single thing is tripled, then I cube it. I take the K and I raise it to the third power. If every one is multiplied by 5, I take the K and raise it to the 5th power. Okay, so this would be K squared equals HCl squared times Cl4 squared over Cl2 squared over CH3Cl squared. Okay, so let's do the questions. The first question says, suppose that a 43-liter reaction vessel is filled with 1.9 moles of HCl, 1.9 of CCl4. Okay, so I've got equal numbers. That means I've got equal numbers here in the balanced equation too. And I've got this is equal to this. Okay, what's going to happen? Well, I've got a huge K. A huge K means I'm going forward more than I'm going backwards. That means I'm making lots and lots of product. Well, if I'm making lots of product, what answer do I give? There will be very little Cl, there will be very little HCl. Well, here's our product. I'm making lots of this, so this is not right. It's this one. I have very little product or reactant because I have a big K. It's going to the right. It's huge going to the right. Okay. Next question. What is the equilibrium constant for the following reaction? Okay, so the following reaction is simply backwards. I've got HCl here and CCl. These are my products, so I've got them backwards. That means I take my K and I flip it upside down. I will invert it. Now, if you don't have a 1 over X button, you simply take 1 and divide by 7.32 times 10 to the 4. But if you do, you just put in your K, 7.32 times 10 to the 4. Okay, now I need 3 significant digits because my original had 3. 7.32 is 3 significant digits. And so my K now is 1.37 times 10 to the minus 5. You see, so the big K turns into a very, very little K when you flip it upside down. If it's big in the right, it must be small in the left. Okay, and then the last one is asking, it's doubling everything and asking what your K is. So if all your coefficients are doubled, then your K must be squared. So I take my original K, 7.32 times 10 to the 4th, square it, and then I want 3 significant digits, and I get 5.36 times 10 to the 9. Okay, hope that helps.